Okay, you were asking about this problem. F of xy equals to natural log of x to the 8th plus y to the 10th plus 1. So let's go through our steps. Okay. We want to find our first partial with respect to x. Well, the derivative of natural log of anything is 1 over that anything. So 1 over x to the 8th plus y to the 10th plus 1 times the derivative of what's inside. But we're taking a partial with respect to x, so everything except for x is a constant. So the derivative of x to the 8th is 8x to the 7th. Y to the 10th goes to 0, 1 goes to 0, because they're both constants. So that gives us 8x to the 7th over x to the 8th plus y to the 10th plus 1. And that's where they get that answer. Let's see. Next thing that they're guiding us to do is to find a partial with respect to y. Well, the derivative of natural log of anything is 1 over that anything. Times the derivative of what's inside with respect to y. So the x to the 8th is a constant, so it goes to 0. Derivative of y to the 10th is 10y to the 9th, and 1 drops away, goes to 0. So we got 10y to the 9th over x to the 8th plus y to the 10th plus 1. Then step 3, what they want us to do is set both of these equal to 0 and then solve them. Okay, so I got 8x to the 7th and then x to the 8th plus y to the 10th plus 1 equal to 0. And I got 10 y to the 9th over x to the 8th plus y to the 10th plus 1 equals 0. Now I can multiply both sides of these equations by x to the 8th plus y to the 10th plus 1, and I'd get 8x to the 7th equals 0, and over here I get 10y to the 9th equals 0, which means we got x is equal to 0 and y is equal to 0. And that's where they get these x equals 0 and y equals 0. Step 4, what do they want us to do here? Determine if there's a relative max or relative min. We use a d-test from the text. Okay, so we need to find this right here. So we need partials of second partials. Okay, so here's our fx, here's our fy. So fx equals 8x to the 7th over x to the 8th plus y to the 10th plus 1. And we're taking the partial with respect to x. So this will be p, this will be q. This is a quotient rule. P prime, partial of this with respect to x, would be 56 x to 6. Q prime, partial of this with respect to x, would be 8x to the 7th. And this drops away because the y is a constant. So we got p prime q minus p q prime over q squared. So partial the partial of fx with respect to x, fxx, p prime, which is 56 x to 6, times q, which is x to the 8th plus y to the 10th plus 1, minus p, which is 8x to the 7th, times q prime, which is x to the 8th plus y to the 10th plus 1 over. Okay, let's try that again. Okay, let me try it again. P prime is this, q is this. minus p, which is that, times q prime, which is 8 x to the 7th, all over q squared. Let's see how far they simplify that. X to the 8th plus y to the 10th plus 1 times 56x to the 6th minus 8x to the 7th, 10x to the 9th. X to the 9th. Partial of this respect to x. Variable y is a constant. Okay, let me try it again. Did I write this down right? 8x to the 7th, x to the 8th plus y to the 10th plus 1. Okay, this is p, this is q. P prime would be 56x to the 6. Q prime would be, okay, I'm working with x's. 8x to the 7th, these drop away. P prime, there, times q, which is that, minus p, which is that, times q prime. You're right, it is wrong. They were taking the derivative of this right here, and that's a constant. They should have been taking the derivative of this. Nice catch on that. So you're right. The step by step is incorrect on that problem.